yesterday we talked about circles. Here are two equations of circles. Now, why do these two look different? These two have a 1 in front of x and y squared, and these two don't. But they're both circles, okay? Now, what is this? This is a circle with a center at 0, 0, and a radius of 5, right?
Yeah.
This, what you would want to do, what did we do? We did a problem similar to this yesterday. What did you do with this? Divided everything by 3. So this is a circle with a center of 0, 0, and radius is 3. Well, what would happen if you had something like this? I'm just making this up. Now what are you going to do? You're going to divide by 3, you're going to divide by 4, you're going to divide by 12. So it's a problem, right? Okay, so when the difference between these two problems and this, these are circles. When these two numbers are the same with a plus sign, you have a circle. When they're different, you have a circle that is distorted. So it looks like a circle has a center, and it has fixed points that are equal apart. So from here to here is 5, here to here is 5, 5, and 5. So it's completely round. We have a radius of 5. Well, for something like this, it's going to end up being a distorted circle. It's going to look something like maybe this, or it could look like, I'm not very good at drawing these, but like that. So it's going to be not, think of a football, how a football's shaped. It's not round, it's not like a basketball or a baseball. It's going to be more shaped like a football, okay? So now, your job today is to look at what, these are called ellipses. You're going to learn how to write an equation of an ellipse, find the fixed points of the ellipse, and how to graph it. Okay, so what is an ellipse? If I were to take a string that's 10 units long, hi.
Did you need third hour?
Yes.
For kids? Take some tests.
Ryan, do you or Caitlin, do you guys want to go, and Gabby, you want to go with Mr. Light to take your test so you don't have to listen to me talk? Follow him. Thank you.
Yep.
So let's suppose you have a string that's 10 units long. We're going to call this D1, and we're going to call this D2. We're going to put these two, these are called your foci, your fixed points. If you took a string that was 10 units long, and then you put like a pencil here, and you were to draw the circle you would have, it would be this distorted ellipse, elliptical shape. So that's what you're doing. And what is an ellipse? It's a set of all points, P. So these are all of your points on the plane, and the sum of these two distances from these two fixed points are going to be constant. And by the way, the sum of these is going to be the length of your major axis. So the sum of D1 plus D2 is the length of your major axis. What you have here, you're going to have a major axis and a minor axis. Your major axis is going to be where it's elongated on. So, for example, try to draw this as nice as I can. Okay? Your major axis is this right here. That's your major axis. Okay? Major axis. Your minor axis is this one. So one's smaller than the other. This is your minor axis. You have endpoints or vertices only on the major axis. This is an endpoint or a vertex, and this is an endpoint. The endpoints are where it's elongated on. Now, from the center to one of your endpoints or vertices, that is going to be your A value. So you're going to have two A's. A plus A is 2A. That is going to be the length of your major axis. So your major axis is 2A, 2A units. So A is from the center to one of your endpoints or your vertices. What's the B value? B is going to be the smaller of the two. So A is the boss. Think of it as the bigger number. B is the smaller. B is the value from your center to one of your co-vertices. So from here to here is B, and here to here is B. So we call this 2B. 2B is the length of your minor axis. Now, how do you know what's the minor and what's the major axis? Well, give me an example. The easiest way is to look at this. You're going to have this. Now, by the way, in an ellipse, you have to set your equation equal to 1. So that question that I asked you before, would you divide by 3, would you divide by 4, or would you divide by 12? Does anyone know what the answer is now? 12. You have to get a 1 here. You have to divide, you look at this. When these two are not the same, it's an ellipse. If they were the same, it'd be a circle. So this is a distorted, think of it as a distorted circle. So step 1, you wouldn't divide by 3, you wouldn't divide by 4, you're going to divide by 12. Now, does anyone know how to get rid of this 3? You want a 1 here. You're going to divide, so think of multiplying by 1/3 or dividing this by 3. So this equation becomes x squared over 4, and then y squared over, this is going to be a 3 equals 1. Which is the bigger number, 4 or 3? 4. You take this is going to be, the square root of this is going to be your A value, so A is 2. So this ellipse is going to be elongated on the x-axis, the bigger number. Now, if these two were switched around, if the 4 was here and the 3 was here, the A value is still going to be 2. A is always the bigger of the two numbers, but where it's positioned is where it's going to be hugging or longer on that axis. So, the two different orientations of an ellipse are going to look like this. Where A is the bigger of the two. A is the bigger of the two. So, if I gave you this equation, and I'm giving you nice numbers, easy numbers. A is going to be 4 here, and B is going to be 3. What this tells me is my ellipse, the center is 0, 0, making them all at 0, 0 right now. You're going to go 4 units on the x-axis. That is a vertex, and that is a vertex. Then you're going to go 3 this way. This is a co-vertex, and that's a co-vertex. It looks like this. Now, those fixed points, those C values that I told you about, always lie from here to here. Here to here is A, and here to here is A. So this is the length of your major axis. 2A, so your major axis is 8 units long. Your minor axis is 6 units, 3 and 3 is 6. Now, your fixed points always lie somewhere on your major axis. It's gonna be somewhere in line here. How do you find it? You use this formula, A squared minus B squared equals C squared. So you take the bigger number, 16, minus 9, adds, what do you get here?
7.
And then the square root of 7 is whatever it is, it's plus or minus square root of 7 units from here. So what is it, 2 point something? What's the square root of 7? I'll tell you. Square root of 7, 2.6. So where is the C value? It's about 2.6 units. This is gonna be your C value, and this is gonna be your C value, 2.6 right here. So how this ellipse is created is if you had a string that long, you're gonna, the distance between these two right here, these are all your points. If you were to add up all of these are all your P values. Do you get it? So the sum of these two is going to equal 2A. Okay? So let's do some examples. It's relatively easy. So I talked about the two different orientations. A and B are going to flip-flop. So, check out this first example. It says, what is the equation in standard form of an ellipse centered at the origin with a vertex? I always like to draw what they give me. If I have a vertex at -6, 0, and another vertex, a co-vertex is going to be at 0, 3, and the center is at 0, 0, this is my ellipse. Right there. So the other vertex is going to be, from here to here is 6 units, so here to here will also be 6. Here to here is 3, and this will be 3. So the length of your minor axis is 6 units, the length of your major axis is 12. 6 and 6 is 12. So, is this one longer on the x-axis or y-axis? X. So what you're going to do, the A value is 6, so you're going to put a 36 here and a 9 underneath the y value. That's it. Easy? Okay, next one. You're going to try this one on your own. What would be the equation in standard form of an ellipse centered at the origin? You draw it. Centered at the origin, and we have a vertex of 0, 5, and we have a co-vertex of 2, 0. So this is what it looks like. So, can you tell me, is this elongated on the x-axis or the y-axis? Y-axis. So right away, I can put my center in, no problem. See, this value from here to here is 5 units. That's your A value, but we're going to put 25 underneath y squared. And we're going to put the number 4 underneath x squared. You get it? So the B, this is your B value. B value is 2, B is 2, and A is 5. You square these, and that's, you put it underneath where it's elongated. Okay? Now, I gave you the relationship between the fixed points. The fixed points are always on the major axis. Remember, A squared minus B squared is equal to C squared. So now they're going to ask you, can you find where those fixed points are? Because that's what defines what your ellipse looks like. So let's take this example. We have 25 x squared plus 9y squared equals 225. Now, how I know it's not a circle is because the numbers, the coefficients in front of x squared and y squared are not the same. Okay, if they were, it would be a circle. So do you remember what I told you to do here? What, are you gonna divide by 25, you're gonna divide by 9, or you're gonna divide by 225? Good job, 225. You want a 1 here. Okay, now, do you know how to get rid of this 25? You're actually dividing this by 25, and you're actually dividing this by 9. The way I look at it is, if I multiply this by 1/25, I'd multiply this by 1/25, so it's 225 over 25. Does everyone see that? This 25 is really, it's 225 divided by 25. So mathematically, how you do that is if you multiply this, to get rid of this 25, if you wanted a 1 here, if you multiply this by 1 over 25, you multiply this by 1 over 25, so it's just like dividing this by 25. So think of this as dividing this by 9, you divide this by 9. So what do you end up getting? You end up getting x squared over 9 plus y squared over 25 equals 1. So if I asked you to graph this, where's the center? 0, 0. The a value is 5 and the b value is 3. You take the square roots of these. So the bigger number is underneath the y, so it's going to be elongated on the y-axis. So this is a vertex, and 0, -5 is another vertex. You only have vertices on the major axis. These two numbers, this 3, 0 and -3, 0, are called co-vertices. Okay, so that's what your ellipse looks like. It's not completely round. This is 5 units, 5 units, 3 units, 3 units. So your major axis is 10 units long, your minor axis is 6. 3 and 3 is 6. Now they want to know, where are the fixed points? The fixed points always lie on the major axis. It's C units. So from here to here is A. C is how many units? What you do, that's your A squared value, that's your B squared value. You take these two numbers and subtract them, and you get C squared. What's 25 minus 9? And square root it. So where are the fixed points that define this? At 0, 4 and 0, -4. Okay, you try the next one. What are the coordinates of the fixed point, the foci? That's your C value. So we have this equation right here. So what would be step 1? Divide by 3,600. So what, you're going to bring this down here. So x squared over, what's 3,600 divided by 36? And then what's 3,600 divided by 100? So this is going to be x squared over 100 plus y squared over 36. Correct? Okay, what's the bigger of the two numbers? That. So this is your A value is 10 and B is 6. So this is going to be hugging, it's going to be, the major axis is going to be under, is the x-axis. So from the origin right here, you're going to go 10 units this way. This is a vertex. 10 units that way. This is a vertex. And you're going to go 6 units this way. And 6 units this way. And so here's your graph of your ellipse. And now they want to know what the C, where is C? C is always on the major axis. So you take these two numbers, this is A squared, this is B squared, you subtract them, and then take the square root. So 64 equals c squared, c is 8. So negative 8, 0, and 8, 0. These are your c values. This is 8, negative 8, 0, and this is 8, 0. This is your c value, fixed points. Okay, next one. Almost done. Okay, this problem, it says what is the standard form of the equation of the ellipse shown? They tell you that, they give you this picture right here. So let's study this for a second. Where is it elongated on? The x or the y-axis? X. It's longer here. Can you tell me, each of these are 2? 2, 4, 2, 4, 6, 8, 10. So this point is 8, 0, and this is negative 8, 0. So from here to here is called the what value? That's your a value. So I know my equation is going to be x squared plus y squared equals 1, but underneath x, what am I going to put? 64. Because it's elongated on the x-axis, so a is 8, so 8 times 8 is 64. Now, they don't tell you what b is, but they do tell us that c is 5. So they don't give you b. B is something we don't know for sure. We know a for sure is 8, and we know c for sure is 5. So you're going to use a squared minus b squared equals c squared to figure out what b is, and that's the number that, b squared is this number that goes here. So what you're going to do is do a squared, which is 64, a squared minus b squared equals c squared. That's the relationship between a, b, and c with an ellipse. So 64 minus c squared equals 25. Okay, and you're going to end up getting b squared is 39 when you do this. When you subtract 64 and divide by negative 1, b squared is going to be 39. So 39 is what goes here. X squared over 64 plus y squared over 39 equals 1. Okay, so you try this one. What is the standard form of an ellipse? We have fixed points at 0 plus or minus root 17. So I know from here to here is c. This is root 17, 0 root 17, and c is also from here to here. This is negative root 17. So I know a is somewhere out here and here, but I still don't know what a is. And it tells me I have a co-vertex at plus or minus 6, 0. So what do I know? What do I know? I know b and c. b is 6, and c is root 17. So what I'm going to do is do a squared minus b squared equals c squared. We don't know what a is. We're going to find it out. B squared is going to be 36. And what is square root of 17 squared? It's 17. So how do you find a squared? Add 36 to 17, and what do you get? 43. So what's the bigger? The bigger number is 43, and where does it go? Under x or y? It's going to go under y because it's elongated on the y-axis. You're going to put 36 here. And you're done. The rest is your homework.